All right, so we're going to start looking at graphed polynomials and see what their zeros reveal. Well, kind of a weird title, but it's actually a very simple lesson. We are going to look at graphs, the pictures, and from the pictures we're going to be able to tell a lot of things, and a couple of new vocabulary are going to be thrown in. So getting right down to it, let's move down so we can see example 1. There's the polynomial, the function, and when we look at this graph, if we were to just type it right into a calculator, we would see a lot of things. Well, first of all, as we were typing it in, we would see that we were putting in 1, 2, 3 x's. So the degree of this is a third degree. We know that means one tail is down, one tail is up. We also know that there are 3 possible roots. Now notice what I have here. These are all sayings, and they all mean the same thing. So on the regions, or me, or any mathematician can bounce back and forth between these 4 vocabulary, and they all mean the same thing. The x-intercepts. Where does this graph cross the x-axis? At 1, at 0, and at -1. So those are my x-intercepts. We could also say those are my roots. We can also say those are the zeros to this function, and we can say those 3 numbers are the solution to this graph. And we could be able to get those quite easily without even having a picture, because we would simply take each factor and set it equal to 0, and then solve each factor. There's our 1, there's our -1, and there's our 0. Okay, that should be all review, and you should be going, whoa, this lesson's pretty easy. And it is. So the new words are written right below. We want to learn what a relative minimum, relative maximum, increasing interval, and decreasing interval are. So the relative minimum, that simply means smallest, lowest point of the graph. So if we drag our little dot out here, you may first say, well, Mrs. Trulin, there is no lowest point of the graph because this graph goes on forever and ever. That would be called an absolute minimum, where this is the absolute lowest point that the graph hits. What we have are relative minimums. So we look for neighborhoods. There is a relative minimum right there. Now, we don't really know what that value is. We just want you to get an idea. It's kind of like this. When you play sports, you have different levels. You have all league, you have all division, you have all conference, you have all county. So all league means you're the best in League 8, which is what Pearson plays in. It means out of the 8 schools in League 8, you're one of the best players. All county means out of the 56 high schools in Suffolk County, you're one of the best players out of those 56. So we're defining our areas. So this area is, we're saying that in this area from here to here, that's the smallest value. Likewise, we have a relative maximum. Again, we don't have an absolute maximum where it absolutely doesn't go above this point, but we have a relative, and it's right here. Once again, you'll learn how to find these absolute value and absolute maximum points, but not right now. We just want you to be able to pick them out on a graph. So that blue dot right there represents a relative maximum. Now, an increasing and decreasing interval are just what they mean. We're going to take our pen and we're going to trace this graph. Wherever our pen is going up, we're increasing, and wherever our pen is going down, we're decreasing. So let's start moving from left to right. We are increasing from here to that blue relative maximum. We are increasing. Once we hit that blue point, we are neither increasing nor decreasing because we're at the top of the mountain, so to speak. So you're not going up and you're not going down. You're at the top. Once we decide that we've seen enough at the top of the mountain, we decide to start walking down, where we go to the bottom. And again, same thing at the bottom. You're neither decreasing or increasing. You're at the bottom. And then, in this case, we started walking up again. Now, we can write this in interval notation if we knew what this point was. And if we knew what this point was. We would then use open brackets. So our increasing interval is stating that we were going from negative infinity, and for right now, just to give you an idea, to our relative maximum, whatever point that was. And we don't know what that point is. It wasn't obvious. And then we use open bracket. And then we had another increasing interval that went from our red relative minimum point, whatever that was, and again, open bracket, to positive infinity. And we had a decreasing interval that went from our relative maximum to our relative minimum. And again, these would have been points if we knew what those values were. And since we had two increasing intervals there, we can say or. Remember that U union, we are increasing from negative infinity to our blue maxima, or we are going from our red minima to our infinity. Okay, we've got another example here. Hopefully we can run through these very quickly. 1, 2, 3, 4. We see it's a degree of 4. That means there are 4 possible roots. We can get these roots by looking at the picture or by solving. 2, -4, 5, and 0. So therefore our solutions, our zeros, our roots, our x-intercepts are -4, 0, 2, and 5. Those are our solutions. Those are our zeros. We can call them roots, or we can call them x-intercepts. They're all the same thing. And if we looked at our picture right here, there we are at 5, there we are at 2, there we are at 0, and there we are at -4. All right. Relative minimum. Can we see where our relative minimums are? We got a relative minimum here. Oops, come on. And we've got a relative minimum here. But this relative minimum is also an absolute minimum, because this is absolutely the lowest this graph ever goes. How about our relative maximum? There's only one of them right here. We don't have any absolute maximum because we don't know absolutely how high it goes, absolutely how high it goes. And again, because it's a 4th degree, both tails are up. Intervals. Well, once again, we have a, let's see, what color did I use here? Decreasing interval. Okay, so decreasing interval went from negative infinity, boom, all the way down to that red dot. Then we were increasing, boom, all the way up to that blue dot. Then we were decreasing, boom. Then we were increasing, boom. Oh, that looks kind of pretty. Now, once again, to write this in interval notation, we'd have to know what these points were. So I'm going to kind of cheat here. I'm going to kind of make them up. These aren't really the real numbers. But let's say this was -2.5, comma, negative, let's say that's 125. I know that's not the real point. I'm just making it up. If you were to write that, decreasing interval, you would say from negative infinity, boom, all the way down to the x value of -2.5, I'm decreasing. And notice I have open brackets because at negative 2.5, I'm neither increasing nor decreasing. And then if we said this was the point 120, and again, I'm making that up. I'm not sure that that's really the point of that maximum. I'd say I'm increasing from negative 2.5, boom, all the way up to 1. So what does that mean? That means if I pick any x value between negative 2.5 and 1, any x value in there is showing that my graph is increasing. And I could say, I have another decreasing interval. Boom, right here. So I'm decreasing here, or from 1, 2, and again, we'd have to figure out what that point is right there. I'm going to lie. I'm going to say it's the point 4, negative 65, just so you get an idea of how to do right increasing and decreasing intervals. And that is going from 1 to 4. And then, or I'm increasing from 4 to infinity. All right, so last one. This time I didn't give it to you in factored form. But by looking at the graph, we can find our solutions, our zeros, our roots, our x-intercepts, because we know our degree is 3. So we're looking for 3 possible roots, and I have them at negative 2, at negative 1, and 2. Wow, pretty easy, isn't this? Negative 1, negative 2, and 2. Boom. My zeros, my roots, my x-intercepts. All right, can we find a relative minimum? Yep, right there. Can we find a relative maximum? Boom, right there. Can we find our increasing and decreasing intervals? Yes. Now I'm going to add one more little thing to it, which we will talk a little bit about tomorrow in class. Make that dot a little smaller. Boom, get right there. Make that dot a little smaller right there. Boom. Okay. It's where our function is positive and where our function is negative. And it really makes sense. We're just going to look at the dividing line, which is the x-axis. So our function is positive anywhere it's above the x-axis. And it's negative anywhere it's below the x-axis. And it's 0 anytime it touches the x-axis. Get it? Because you're either one of 3 things. You're pro something, you're anti something, or you're undecided about something. You're pro something, you're anti something, or you are undecided about it, which means you are neither pro nor con. See you tomorrow.